Okay, so let's start to we had ended with web caches, that is also known as a proxy server, and we had seen that how does it work and how does it help in faster transmission of data. Okay, so we had learned up to web caches. The next thing that we need to learn or start learning today is about conditional get. Okay, so there were certain questions that were asked the last time, that what if the data has been modified at the server, or what happens if some data needs to be modified, and then the client asks for it. Okay, and I had answered that in those cases we will see that there is the use of conditional get statement that is used, so that we can avoid any inconsistency issues related to updating a document. Okay, so suppose there is an object, and the most updated version which is there at the server, your web cache also tries to pull it from the server because some other person had requested it at that time. Okay, now it doesn't make any sense to always, because you know that there was an update that was made in the object, so without checking the web cache, just go ahead and get that from the server. That does not make sense, right? So first you need to check at the server, check at the web cache, sorry. You have to check out the web cache and see that whether the most updated version is available to you or not. If it is available, great, take that. If it is not, only then you ask the server for a newer version, and that too the client does not need to talk about it. The web cache is anyways going to act as a client for the server, right? So the statement that we use in order to find out that whether we have the most updated version or not, that is known as conditional get. Okay, so as I mentioned, that the goal is that the server does not need to send the object if the web cache already has an up-to-date cached version. Okay, why is it used? So that you have lesser and lesser transmission delay for transmitting the object. Okay, and you use minimum number of or minimum amount of network resources. So how does the client work? So whenever the client is sending an HTTP request, it will send this extra line with it, which is if the object has been modified since a given date. That means if you have some data which is like 1 month old, so when you are sending an HTTP request to the server, you will simply put this conditional get statement, that is if the object has been modified since your last up to date value that you had. Okay, so now if the server says that yeah, there has been no change. Okay, so in that case it does not contain the object, I mean the new the new updated object, because it knows that you already have that data with you, right? So therefore, what it does is it does not send the object, it simply sends this message that HTTP 1.0, the version, and the statement that it gives out is that 304 not modified. Okay, so the server simply sends the answer to your web cache that yeah, you already have the up-to-date version, there has been no change. But if it was modified, then the server would have to respond with the newly modified object. Okay, so it works something like this. So your client sends the server that HTTP request message with if modified since the date. Now at the server, if the object is not modified before a given date, the date that has been given by the client. So in that case, if the data or if the object has not been modified, then the server will simply reply as HTTP response and 304 not modified. Okay, this statement will be replied by the server. Now, this is another scenario where you have sent the HTTP request message, or the client has sent the HTTP request message with the if modified statement, that means the conditional get statement. Now, with this, when this statement reaches the server and the server finds out that yes, there was a modification done on this object before this given date, that means the cache does not have the up-to-date version of the object. So then the server responds with the most up-to-date version of the object. Okay, and this is the statement that it gives out, that is HTTP, the version that is 1.0 is being used now, and 200 OK. Okay, and then the body will contain the data, that means the object that has been modified. All right, so this is how your conditional get statements will work. All right, so after this we are going to look at the different versions of HTTP that are available. Okay, so we have learned about HTTP 1.0 and HTTP 1.1, right? So today we are going to look at few more versions of HTTP. So starting with HTTP 2. Now let's first start with what are the properties that HTTP 1.1 gives us. Okay, so what is the main goal of HTTP? The main goal is that you have a decreased delay when you are trying to access multiple objects through HTTP requests. Okay, that's our main goal, because at the end of the day, you always want the user to have a good quality of service experience. Okay, and via internet, if we are talking about a good QoS experience, that means you want to give as less delay as possible for the user. Now, what does HTTP 1.1 gives? HTTP 1.1 actually introduced the concept of multiple transmission of objects. Okay, um, so that you have a lesser amount of delay. All right, so you can have some pipeline gets or pipeline get statements you can have, so that you can get multiple objects that were requested for from the client side over a single TCP connection. Okay, so as I had mentioned during the persistent and impersistent connections, right? So there, what was happening? See, in case of persistent connections, you can keep it open. The TCP connection can be kept open until all the objects are being transferred. Whereas in case of impersistent HTTP, in order to transmit multiple objects, what could be done, that you can actually open parallel connections together, so that the transmission can happen faster. Okay, so similar concept is being used in case of HTTP 1.1, that you can have pipeline gets or pipeline get statements you can send over a single TCP connection, so that multiple transmission of objects can be done. Okay. Now, how are these multiple transmissions done? See, you are sending pipeline gets, right? So what the server does is, whenever it gets a get statement or receives a get statement, it will respond according to how it is receiving. That means in the FCFS manner, it will try to schedule the get requests. Okay. So what will happen if you have some object which is of a very large size as compared to all the other objects which are to be transmitted? Now, somehow due to the FCFS way ordering of transmission or responding from the server side, the object which is having the larger size, that got scheduled first. Okay, so that means the transmission of the object with the larger size is getting transmitted first, and all the other objects which came later on, and they are getting transmitted later. Okay, so the transmission of a larger object will take a larger amount of time. So, what's happening, even though these objects could have been transmitted faster if the smaller objects could have been given a chance first, but that could not happen because they are waiting because of the bigger object that has to be transmitted from the server side. Okay, so the concept that some objects are waiting because of one bigger size object that is ahead of them in the queue for transmission. That concept is known as head of line blocking. Okay, so that means other objects or object is waiting for transmission because there is some object or objects which are bigger in size and they are taking more time for transmission, leading to delay in transmission for the other objects which are behind it. That is known as head of line blocking. Okay, so this basically leads to stalling of transmission and also loss of uh, the data. All right. So let me show you. Okay. Okay, I'll show that diagram after one more slide. So let's see what else HTTP 2 gives us. Okay, that was HTTP 1.1. So HTTP 2 also has the same objective, that is you want decreased delay while you are transmitting multiple objects when an HTTP request comes. Okay, so now for HTTP 2, what do you want? You want increased flexibility at the server so that you can send objects to clients. Okay, now what are the ways in which we can send objects to clients? We can use different methods, status codes, and then header fields. Now, as compared to HTTP 1.1, in HTTP 2, most of the methods, status codes, and header fields remain unchanged. So you use similar methods, status codes, and header fields as was given in HTTP 1.1. What changes in HTTP 2? See, the problem that we faced in HTTP 1.1 was the FCFS ordering, right? So that is what changes in HTTP 2. So no longer at the server side, whenever the server receives some request, okay, it serves the client according to some specified priority rather than how it was serving earlier in HTTP 1.1, that was in FCFS order. Okay, so what it does basically, it basically pushes unrequested objects to clients. And what else HTTP 2 provides? So in order to do this, that is in order to transfer data according to some priority and to make more efficient use of the resources available, what HTTP 2 provides is it provides the way of dividing the objects into small frames. Okay, so what it does, it allows the division of objects into smaller frames, and then these small frames are then scheduled so that head of line blocking or H2L blocking can be avoided. Okay, now see, this is how, this is what I was talking about. So this is in an HTTP 1.1 scenario. Okay, so what's happening in HTTP 1.1? What it allows? It allows pipeline gets, right? So see here, there are so many get requests which are pipeline and they are going to be received at the server one by one, right? So the client requests one large object. Okay, that means suppose one video file is there and some small images are there. Okay, so we have one large object and three small objects here. Okay, so for example, object O1 is the one that is the video file, and the rest of the three objects are images. Okay, so what was happening with HTTP 1.1? Due to pipeline gets, these are all transmitted to the server and the server receives them one by one. So how would it serve? As per HTTP 1.1, it will serve according to FCFS. That means the way it has received the request, it will start responding to the requests in the same order. So it received get O1 and then it will respond according to that. O2, O3 and O4 like that. Okay. Now O1 is this big an object. Okay, the blue colored ones. Okay. Whereas O2, O3 and O4 are smaller objects, comparatively smaller objects. So you can see that these are pretty small, but they are to be transmitted later on after O1 is transmitted. Okay. So see how the transmission is happening. Okay, so the transmission for O1 took a large amount of time. Only after that, only after O1 was fully transmitted, O2 transmission of O2 started, then O2's transmission finished, then O3 and O4 were subsequently transmitted. Okay, now you can see that all of these, that is O2, O3, and O4, they had to wait for O1 to be transmitted. Okay, which took a long time to get transmitted. All right, so eventually it is leading to a lot of delay for transmission of these smaller objects, that is O2, O3, and O4. Okay, so now what was done in case of HTTP2? Okay, so in HTTP2, what was given out that the extra feature that HTTP2 provides is you can divide the objects into frames, right? And then prioritize the transmission. Um, Now here, see, you have conditional, you have pipeline gets, okay, same in the as it was given in the previous scenario. So you get an O2 and O4 from client side to the server, okay. Now this is at the server side. This is how the requests were received, okay. But what is happening here? The objects are being divided into frames, all right. So you can see O2 and O4, they are of very small size. So all the other frames are kept as similar sizes, O2 and O4. O3 is divided into two frames, and O1 is divided into several number of frames. Okay. Now was also transmitted earlier, and then O3 took some time, and O1 could be transmitted later on. It's not that nothing of information was coming in between. Okay, so this basically reduces the experience that the user gets at the end while receiving the data from the server side. You don't have to wait entirely for all the data to come. Okay, and also it avoids what we were looking for, that is head of line blocking is avoided with this concept. Okay, now some more properties of HTTP2. Okay, so HTTP2 over single TCP connection. What does it mean? That recovery from packet loss will still stall some object transmissions. Okay, why? Because in HTTP 1.1, our browsers have the incentive to open multiple parallel TCP connections. Okay, so that we can increase the overall throughput. All right. What else does HTTP 2 have? It does not have any security feature. Okay, so there's no security feature over TCP connection. Now, what does HTTP 3 give us on top of HTTP 2? So HTTP 3 will simply add security on top of HTTP 2. And one more thing that HTTP 3 gives us is that HTTP 3 uses UDP instead of TCP. Okay, so essentially HTTP 3 adds security. How does it do it? And also what does it add? It also adds per object error and congestion control. Okay, so it does all of these over a UDP connection. Okay, so now if there was any question that whether UDP connections are being used or not, so this is your answer. UDP connections are still being used. Okay, so few much more of HTTP3 we will read in the transport layer chapter, but as of now we have to just know that HTTP2 does not provide security. over the TCP connection, whereas HTTP 3 does provide per object error and congestion control over UDP connections. Okay. All right. Now, before I move to the next part, so I want to give some assignment to you. So the assignment is about HTTPS. Okay. So in this book, they have not talked about HTTPS, but HTTPS, I think all of you have seen it, and it is good to know. I mean, all of you should know what is HTTPS and how does it work. Okay. So there are only a few changes in HTTPS. You know what is HTTP 1.0, 1.1, HTTP 2, and some parts of HTTP 3 also. All right. So what is HTTPS? What are the features of it? It will be good if you all take a look at it. Okay. So this is an assignment for all of you. Please note what is HTTPS, what is the underlying transport layer principle, what are the features that HTTPS provides, and why is it that we use HTTPS nowadays. Okay. So these are certain questions that I would like to ask sometime either during quiz or during Viva or anything. Okay. So this is a very important question. So get an answer for this. If you have any doubts, you can always ask me. All right. Let's start with the next part of application there. So today we are going to look at email and the corresponding protocols that I use to achieve this, that is SMTP, IMAP, etc. All right. So what does an email contain? What are the major components of an email? Okay. So for sending or receiving emails, the first component is your user agent, right? The user agent is the one who's either the sender or the receiver of the email. Then what we have? We have the mail servers. Okay. And then we have a protocol which is known as simple mail transfer protocol, which ensures the transmission of data from each of these mail server. Okay. So if you can see here, there is no direct communication between user agents happening. Okay. What's happening here? The user agent will actually send its information to the mail server, or basically if you are writing an email and you want to send it to somebody, your transmission is happening with the mail server, or your communication is happening with the mail server. From your mail server there will be a communication that will happen to the recipient's mail server. Okay, and that communication happens via SMTP protocol. Okay. Now, whatever mails you are receiving or you are keeping in your storage, everything, all the data is at the mail server side. Okay. Whenever you want to read that mail from the mail server, then the communication will happen again from the mail server to the user agent. Okay. All right. So that's what I just mentioned. What is user agent? User agent is the one who's the mail reader. His task is composing the email, editing, reading the mail message, etc. So this is done with the help of, we have Outlook and we have other mail clients like iPhone, Gmail, etc. And what do we do? That whatever outgoing message you are sending, that is sent to the mail server, and whatever you're receiving is also received at the mail server only. Okay, the you as a user or the user agent only accesses the mail server, the content of the mail server, to just read the emails, whatever you have received, or to send the emails. Okay, all right. So now we are going to look at the second component, that is the mail server. Okay, so what does the mail server contain? So first it will contain the user mailbox as has been given here in the diagram too. Okay, so the user mailbox will contain all the incoming messages of the user. Okay. And what is the next part of the mail server? that is a message queue that will hold all the outgoing messages from the user side. Okay. So if you have any outgoing messages, it will be sent at the message queue and specific to the particular user. Okay. Now, how the mail servers communicate with each other? They communicate with the help of the protocol known as SMTP or Simple Mail Transfer Protocol, which is basically a protocol that is established between mail servers so that they can exchange the email messages. Okay. So whenever there is a user that needs to send the message, it will send its own mail server, and it will compose a message. It will stay in the message queue of the corresponding mail server, and that mail server will now act as a client because it is going to send the email. Okay, and the recipient of the mail will be the server. Okay, the server side, we'll call that the server because we are dealing with client server architecture here. So one has to be a client, another has to be a server. So that is why the one who's sending the mail is the mail server from which the mail is being sent is acting as a client, and the mail server which is receiving the mail is acting as a recipient or the server side. Okay. So some of the properties of the SMTP protocol, so that is given in the RFC, that is request for comments, that document of SMTP. Okay. So what are the features? So first of all, SMTP uses TCP. Okay. So can anybody tell me why SMTP uses TCP? Why do we need TCP connections for transferring emails? Any answer to this question?
Ma'am, for its reliability.
Yeah, reliability is written in the slide itself. Can you just explain what do you mean by the reliability part here?
TCP ensures that the data is reliably sent, that the user will end up with the email, but there can be loss of data if we use UDP. So,
Hmm. So that means you have to ensure that there is no loss of data when you are transferring the email, right? Data loss is not will not be accepted, right? So it is not acceptable to have any kind of data loss when you are dealing with emails. So that is why TCP is used. Okay, so if you remember the table that I had shown in the last class, where we had seen that what are the different types of applications which use either TCP or UDP, and what are their requirements. Okay, so we had seen that when it comes to emails, the reliable data transfer and the guaranteed data transfer, that is what is important for emails. Okay, you don't need that, you have to transmit the data within a given amount of time. So time is not a constraint. The constraint is reliability. All right, so that is why TCP is the underlying transport layer protocol when it comes to emails, right? So we have SMTP, which is used for transferring emails from one mail server to another, and SMTP uses TCP as the underlying transmission layer protocol, and this is for reliable transfer of data. So as you can see here, we have a client SMTP server and we have a server SMTP server. So the client one initiates the TCP connection, and as usual, first a connection will be established, which will take one round trip time. Okay, and only after that there will be transmission of data. Okay, all right. So same three phase of transfer as we have already read about TCP. So see, this is the handshaking part that is happening. So first you have the initiation of TCP connection, and then the server response that the connection is initiated, that is one round trip time. Then you have some data that is transferred. Then you have the response from the server side. Then it goes on. All right. So there are three phases that you have. You have SMTP handshaking, which includes the establishment of connection and sending of hello messages. And then you have the actual transfer of data, that is SMTP transfer of messages. And then in the end, there is the closure of the connection. Okay. So that is why, because you have these three phases that should be there for transmission of data. So we have three phased SMTP transfers. Okay. So how do we send any command or any request via SMTP? It is similar to HTTP, where we send some commands or response um, in each of these responses that we get during the communication. The commands are in ASCII text, and the responses are same as in HTTP, that is a status code and a phrase. Okay. So here there is a scenario where Alice sends an email to Bob. Okay, so step by step we will see what happens when a user sends an email to another user. Okay, so Alice uses some um, some kind of user agent, that is like either Outlook. Let us assume we are using Outlook. Okay, because this is what we are using most of the times. So Alice uses a user agent to compose an email message. Okay. And the message is to be sent to Bob. And this is Bob's email ID. All right. So what does the user agent do? So the Outlook that Alice has on her system, that is a user agent, right? So that user agent, what it will do, it will send this composed message to the corresponding mail server. Okay, corresponding mail server using SMTP. Okay. Now, what does this mail server do? What we know that at a mail server, the messages which have to be transmitted are queued. Okay, in the message queue. So the green one, which is known as the message queue, outgoing message queue. So that is having the message that now Alice has sent to Bob. Okay, or Alice wants to send to Bob. So in step 2, via SMTP, that message has reached this queue at the mail server, which is Alice's mail server. Okay. Okay. Now what will happen? Now Alice's mail server has to connect with Bob's mail server so that it can transmit that mail, right? Transmit that message essentially. So what we have learned that if we use SMTP, the underlying transmit layer protocol is TCP. Okay, so before having any transmission done, the TCP connection needs to be established. So that's going to be step 3. Because Alice is the one who's going to send the email, Alice's mail server will become the client side now. Okay, so the client side will now initiate a TCP connection with the server side. And which one is the server side? The Bob's mail server. Okay, so now this is happening. Okay, so once the connection is established, then Alice's mail server will actually send the message from Alice to Bob, okay, or Bob's mail server via the TCP connection that was established at step 3. Okay. Now, once this happens, what we know that all the messages that are received, okay, they are stored in the mailbox in the mail server itself. Okay, so Bob's mail server now has this. You can see that the yellow colored ones, those are the incoming messages, all the messages that are incoming for Bob. Okay, so that's the mailbox for Bob, and it is stored in the mail server. Now, what will Bob do? Now, when Bob wants to check his email, he will use his user agent, and his user agent will basically pull the messages from Bob's mail server for Bob to read. Okay, so this is how an email message transmission happens. All right. So these are some sample SMTP interactions. Okay, what we know about SMTP interactions, because it is same as HTTP. That means the responses happen in the form of statements, commands. All right. So this is the server side. This is the client side. Okay. So this is just a message exchange that is happening. Okay. So first we know that there is a handshake that happens, right? After the TCP connection is established, then there is a hello hi handshake that happens. Only after that you transmit any other data. Okay, so that is what is happening here. Okay, so first there was a connection that was established, there was a handshake that happened, and then there is this. From the client side you can see that there is a mail from Alice, and then there's a transfer that happens. Then you have the client side that is received to bob at hamburger.edu, and so on and so forth. Okay. All right. All right. So this is just a communication that's just going on. Okay. So that's a lot of data after your basic first step handshake is done, and then you know that who is the sender, who is the receiver, and what data has to be sent. So when it comes, so the client side is now, there is an exchange of messages that is happening from the client side to the server side. Okay. All right. Now, once the message is accepted for delivery, then the client side will close the connection with this command, that is quit, and then the server side will also close its connection. Okay. All right. So as we said that SMTP is similar to HTTP itself, but what are the small differences that are there between SMTP and HTTP? That's what we are going to see in this slide. So first is comparison with HTTP. So first thing is that in HTTP, the client actually pulls the data from the server side. Okay. Whereas in SMTP, client pushes the data to the server side. Okay. So as you have already seen that, the client is the one who actually sends the email. So that is why client is the one who pushes the data. Whereas in case of HTTP, the client can use get statements to, get the object from the server side. So that is why there is client pull. Okay. And both of them use ASCII commands as response, and their responses are also in the form of status codes, right? In HTTP, what happens? Each object is encapsulated in its own response message, right? Whereas in case of SMTP, multiple objects can be sent in multi-part message. So as you saw in the this last example, right? In SMTP, you can use, multi-part objects can be sent over this same connection, right? Whereas in case of HTTP, each object that was being received that came with its own response message, right? If you remember, the response message had its own header lines, and then at the data part there would be the object. So each object that is being received has its own response message. Whereas in case of SMTP, you have multiple objects which are sent in multi-part messages. All right. So since SMTP uses multiple objects that are sent in multi-part messages, only persistent connections make sense, right? Otherwise, every time there is a connection, there is a transmission, then the connection will be disconnected, and then again there has to be connection establishment and so on and so forth, which will not allow, of course, the features that SMTP provides, right? So SMTP uses persistent connections. Okay, it requires the message to be of 7-bit ASCII, and the line feed also. Okay, so carriage return and line feed, both of these are used to determine end of a message, same as what was happening in HTTP. So if you remember HTTP request and response messages, the sorry HTTP request messages, if you remember, in response messages also, the end of lines were considered with the help of carriage return and line feed. So in request messages more so, in response only the first part had carriage return and line feed. Okay, whereas in case of SMTP also you use carriage return and line feed in order to determine that what is the end of the message. Okay, so what should be the protocol for exchanging email messages? Okay, so you know that how an email is written, right? You all are aware of how an email is written, but then um, there should have been some particular protocol, right? Some protocol should have been established so that everybody in the world writes the messages in the same way, right? That means, what do we have? We have a particular syntax for the email message. Okay, and what is that syntax? You have the header lines where you have the to, from, and subject, and then of course you have the body. Okay, so this is a universal rule or set of protocols that have been accepted and have been given out by request for comments for mail message format. Okay, so it's not like somebody just came up one day that this is how an email has to be written and they just and everybody started following it. It's not like that. Some people came up with it. They made a request for comment, and then everybody has to use these RFC documents, which is why all the user agents that you have, they use the same format for sending the email or composing an email. All right. Okay. So this is how it happens. Now let's get to the next part. Okay. So what we know by now, that the user agent, when it wants to send a message, it sends the message to its corresponding mail server using SMTP. The mail servers communicate with each other using SMTP. Alright. Now the question that comes is that the user agent at the server side, that means the recipient user agent, the recipient user agent's task is to just read the message that has been received at the mail server. Right? What is the task of SMTP? Task of SMTP is delivery or storage of email messages to the receiver's server. Okay, so SMTP works only up to the receiver's mail server. Okay, that's what its task is. What is the task of the receiver's user agent? Receiver's user agent is only responsible for helping the user read his or her messages or accessing the messages. You can either move the messages to trash, you can keep them in separate folders, you can do whatever you want, and and that is happening at the user agent's side. Okay, for those interactions, you do not need SMTP because SMTP's task only is to deliver or storage the data. So for this communication, the last leg from the receiver's email server to the user agent, we use email access protocols to actually access the emails. Okay. So for this access at the last leg or the last hop, we can see. So at this last hop, some example protocols that are used for email access are IMAP and HTTP. Okay, so HTTP we have already studied. Okay, so what is IMAP? IMAP is Internet Mail Access Protocol. Okay, so what are the properties of IMAP? What does it do? So it basically helps to retrieve, delete, or store messages in different folders in the mail server at the users at the end user side, right? Like the receiver side, basically. Now we already know what is HTTP. We have already studied. Now, which of the user agents use HTTP as their email access protocol? So these are some example user agents like Gmail, Hotmail, Yahoo Mail, etc. They provide a web-based interface on top of SMTP. Okay, and they also may use IMAP or POP to retrieve email messages. HTTP is mostly used in case of Gmail, Hotmail, and Yahoo Mail. Okay, all right. So before I get into the domain name system, um, any questions on the previous parts?
Uh, Hello, ma'am. Am I audible?
Yes.
Ma'am, in one slide was mentioned that SMTP there are only like push requests, whereas in
Mm-hmm.
HTTP there are like pull requests only. But like
Mm-hmm.
when we fill a form using HTTP, then doesn't that count as a push type interaction too? Because we're pushing data onto the server.
See, HTTP actually allows push and pull both. You are using get statements to pull the data from the server using HTTP, right? And you can also send an object, or if you are saying a form in this case, so that is using a post method, you can send it to the server side. Okay. SMTP, however, does not provide the pull method at all. So when we were saying a comparison, it was said that HTTP provides a pull message. SMTP does not provide a pull message from the client side. It always provides a push from the client side. Okay?
Okay, ma'am. I understood. Thank you.
Yeah. Okay.
Regarding conditional get request.
What conditional get request?
In that, ma'am, you told that the client asks the server if the data is modified before some particular time, but shouldn't it be the opposite? Like, why should the client worried about if the data is modified